You're fine. You're fine. It's all right. You do not have to do the Desmos at all, but you do have to do the cami. The cami is required. Thank you. I'm gonna I'm gonna try not to say names while I'm recording, just because if I do, I'm gonna have to go through and edit everything out. I guess I could say first names. I don't think that would be a problem as long as I don't say your last name. All right. So on Friday, most of you have done this. I've graded the notes and they look really nice. Y'all did a good job on those. On Friday, you did a lesson on interior angles. And so you know interior means inside. So interior angles are on the inside of triangles. Today's lesson is on what we call exterior angles. And I'm going to show you what an exterior angle looks like as we go through this. But our objective for today is to understand the relationship between exterior angles of triangles and the interior angles. So there is a relationship, and there are ways that we can find an unknown measure by using those exterior angles. Okay. All right, so let's look at the top part of our notes where it says exterior angles, and we're going to fill in a couple words here, and we're going to talk about this. Hopefully, I know that interior angle lesson is pretty easy. They all add up to 180. So if you know two of them, you can find the third one. This lesson, to be honest with you, to me is pretty easy if you just understand what the terms mean, like which angle is which, okay? So an exterior angle is formed by one side of a triangle and what we call the extension. So we're going to write the word extension here. And y'all, my handwriting is terrible on this thing. The extension of an adjacent side. Adjacent means beside, or they share a side. And we'll talk about that in just a minute. I'll show you exactly what I mean by that in just a minute. In the triangle to the right, in this triangle over here, angle 4 is considered an exterior angle. Okay, so, and the way an exterior angle is formed is this. So if I took one side of the triangle, like this bottom side, and I extend it like this, okay, that forms an exterior angle. So the exterior angle that is formed when I extend that side is angle 4 right here, that angle right there. Okay, so angle 4 has a sort of a relationship with angle 1 and angle 2, and that's what we're going to talk about today. All right, so angles 1 and angle 2, I'm going to highlight these, and you don't have to do all the highlights that I do, but angles 1 and 2, I'm going to highlight them in red. Those are called remote interior angles, okay? So those are called remote interior angles. And those are the angles that when you make that exterior angle, they're the furthest away. Do you see how angle 3 is beside angle 4? Angle 3 and 4 are what we call adjacent angles. So angle 3 is not involved in this equation. I'm just going to mark it out. Okay. Angles 1 and 2 are called remote interior angles. Remote means far away, right? Remote means if I'm using a remote control, that means I'm controlling something that's away from me, right? Evie, did it work? Are you good? My chat's not frozen, is it? All right, can somebody type in the, okay. No, you do not have to do the highlighting. You can do however you want, and I will show you another way that you can mark angles if you don't want to do the highlighting. Highlighting is something that it would probably slow you guys down. So no, you absolutely don't have to. All right, cool. Remote interior angles are two interior angles that are not what we call adjacent. Now the word adjacent just means beside, okay? So it doesn't touch the exterior angle. So number 3, angle 3, not a remote interior. 1 and 2 are remote interior angles. For example, in the picture above, angle 4 is the exterior angle, and angles 1 and angle 2 are the remote interior angles. Okay. So what I want to do for this next section. This next section takes too long to go through to sort of discover the different angles, okay? So what I want to do is I'm just going to tell you how this works. So what you can do is you can actually mark out this part right here. We are not really going to look at that. What I'm going to do is I'm going to show you with these different exterior angles how you can find the value of those angles, okay? So I'm going to try to talk about them and highlight some things, but let me do this. All right. So if I told you angle 1, I'll do different colors. Angle 1 is 130 degrees. A couple different ways I could find that. First of all, with the 50, the 130 makes a straight line. So I could just subtract 50 from 180. So that works. But there's another way I can find that as well. So angle 1 is 130 degrees. Let me grab a different color here. Angle 2 is 110 degrees. Okay, so 110 plus 70, that's 180. So that's one way I could get that. Let me get a different color here. Let's do, hold on a second. Let me get a blue. Get like a nice teal. I love teal. Angle 3 is 120 degrees. So 60 plus 120 is 180. They're on a straight line. Okay, but there's another place that I can get these measurements. All right. And that is from the remote interior angles. Let me show you what I mean by that. 130 is also, let me grab my green, is also 70 plus 60, right? 70 plus 60 is 130. Okay, well, this angle right here and this angle right here are remote interior angles to angle 1. So if I look at angle 1, okay, look at all the interior angles. Well, the ones that are farthest away from it or that are remote to it are 70 and 60. If I add up 70 and 60, I can get angle 1. Okay? So if I didn't have this one, if I didn't know what this one was, and you don't mark this out, I'm just showing you, I'm going to erase that. If I didn't have this and I wanted the measure of angle 1, I could just add 70 plus 60 and I would get the measure of angle 1. I'm going to erase where I marked out the 50. Okay? Angles, hold on, let's see. Angle 3 I did in teal. Okay, so how would I get the 120 if I didn't have the 60? Well, what I would do is I would add the 70 plus the 50. So we would do 70 plus 50 and we would get angle 3. Because angle 3 is exterior here, the interior ones that are furthest from it are the 70 and the 50. All right, angle 2 is 110. If I wanted the measure of angle 2 and I didn't have this one right here, I could add the 50 and the 60 because those are remote interior angles to angle 2. Now, that might have been too much to take in right now. That's okay. Let's look at some examples and hopefully it will be clearer. Okay, does anybody have a question about what I've said so far? Is anybody following me? Give me a yes if you're following me so far. That was a lot. Okay. All right. Uh-oh. Somebody said my page went black. Try refreshing. Let's see. Who was that? Lucy. I think Evie was having the same problem, and she, I believe, was able to get hers back by refreshing. Try that. Okay, let's look at some examples. Let's go down to let's answer this. From this example, we can conclude that any exterior angle is equal to the sum of its two remote, just meaning like the opposite sides. Oh, good. Interior angles. Okay, let's look at number 2. And I'm going to make this one a little bit bigger. Also, after the lesson today, I have put an optional Delta Math assignment on the modules. I just did that a little while ago. Just in case, if you get this and you're good at it, don't worry about it. It doesn't count on your grade or anything. But I did put an optional Delta Math, which is a really good Delta Math that I found. Okay, so I'm going to start color coding these. Again, you don't have to do this, but I'm going to color code these. I'm going to highlight the exterior angles. You know what? Let's look at both of them at the same time. I'm going to highlight the exterior angles in green. So the exterior angle on number 2 is 115 degrees. The exterior angle on number 3 is x. So do you see how the side has been extended? Let me get a thicker. So you see how this side has been extended right here? Right? And hang on, I need a straight line to make sure I can do this one. Wrong color. There we go. So the side has been extended and it forms that angle on the outside of the triangle. Okay, so those are the exterior angles. The remote interior angles, they give them to us. They show them to us. The remote interior angles for number 2 are 54 and x. The remote interior angles for x in number 3 are 66 and 50. Now, it really depends on which exterior angle they give us. They only gave us one, so it's pretty easy to figure out, okay, these are the remote interior angles. So, every single time on these, pink plus pink equals green. Okay, so pink plus pink equals green on all of these. So we can set up an equation on these if we want. We don't have to, but if if you need to, we can. So x on this one, number 2, x plus 54 equals 115. On number 3, just move over here real quick. Again, pink plus pink equals green. And I would also put, you could also put 66 plus 50 equals x. Okay, so it's going to equal that exterior. So 66 plus 50 equals x. Okay, I'm just working these sort of in tandem, just so you can see that they're the same. The two remote interior angles add up to equal the exterior. Sometimes they give you x on the inside, sometimes they give you x on the outside, but you set it up the same every time. Okay, so on number 2, we have a one-step equation. X plus 54 equals 115. So if I subtract 54 from 115, minus 54, that'll give me what x equals. And that's all we're asked for in this one. What does x equal? Okay, so x equals 115 minus 54 is 61. So that's our answer right there. It's going to get a little bit more complicated in the next few problems, but that's all there is to that. Does anybody want to take a try at what x equals on number 3? On number 3, yes, I'm sorry. Yeah, I was looking at the wrong one on my key. Yes, 66 plus 50 equals x. And yes, that would be 116. So 116 equals x, or x equals 116. Good. Okay. How are y'all doing so far? Give me a percentage. Okay, good. All right, nice. Okay. So again, if you want more practice on this type of problem and more practice on Friday's problems, there's a Delta Math. And it starts out with Fridays, and then it goes to this, and then it's going to go to what we're about to do next, which is a little more complicated. But as long as we can figure out how to set up the equation, we can graph these, y'all. And that's what we're going to do, okay? And so I will go to a different screen from here, and we will graph these. Okay, so let's look at number 5 together. The first thing we need to find is x. Okay, so again, you don't have to highlight these. You can circle them. You know what? Let's do that. I'll circle them instead. So I'm going to circle. Let me get a pink. I'm going to circle the remote interior angles in pink, or you can underline them. Let's do that. Underline. So 2x and 70 are the remote interior angles for the exterior angle 4x plus 10. So the two pink ones equal the green one. So pink plus pink plus pink equals green, right? So that means 2x Oh, let me do a neutral color here. 2x plus 70. I don't have enough room. Let me try that lower. 2x plus 70, so those are the two pink angles, equals 4x plus 10. Yes, good. Okay, you can solve this equation. Totally fine. If you solve it, you're going to probably subtract 4x from both sides, subtract 70. You will end up with x equals, let me just give you, x equals 30. You can also go over to Desmos Graphing Calculator and graph this, and I'm going to show you how to do that right now in case you don't remember. Let me get rid of these. Okay, so on two lines, we're going to put a y equals. And remember, you have to use lowercase, y equals. On the first line, let's write our equation here. Hold on a second. So our equation was 2x plus 70 equals 4x plus 10. So on the top line, I'm going to put this right here, 2x plus 70. Y equals 2x plus 70. Remember, it has to be lowercase or it won't graph. Okay, 2x plus 70, there's 2x plus 70. On the second line, I'm going to enter 4x plus 10. If you can solve equations, it's probably faster for you to solve it. But you can also check your answer with this too. Okay, there's the intersection. We see the intersect. Y'all, I'm sorry. I thought I was sharing my whole screen, and I meant to. I am so sorry. Let me try to share my whole screen again. Okay. That's still not screen 3. Okay. The graphing, Madison, it does, except when you have a number, then you still have to put in like y equals 180 or whatever. It does. Please show the definition page again. Yes, Shri. Give me just a second. Let's look at this intersection and then we'll go back over there, okay? All right, so here's our intersection, and we got 30 when we solved the equation, and x equals 30 on here also. What Madison was saying is that it works not to put the y equals here. The reason I tell you to put the y equals is because it's just a good habit to get into, because these are lines, and that's part of the equation of a line. So we're going to be looking at y equals different equations later when we get to our linear functions. Okay, so hopefully this works. Okay. I wanted to share my whole screen. Okay, so x equals 30. Shri, what were you talking about? This part up here? I will share these completed notes with you guys at the end of the day. And I will also share this video that I'm recording right now at the end of the day. Okay, so you'll be able to go back and get that filled in. Also, if you have like half of the notes, I'll give you credit. Okay, so before we go any further on number 5, I want to look at number 6 and do x on number 6. Okay, so what I know is 81 plus 12x equals 24x plus 9. So as long as you know that, you set up this plus, that should be pink, sorry, this plus this equals this, what we've got in green. So let's write it. Just write it exactly like what we just said. 81 plus 12x equals 24x plus 9. If you want to solve it, you can solve it. If you solve it, you're going to get 72 equals 12x, x equals 6. Let's go over and check it on Desmos. So our equation, I'm going to just make these invisible. And I'm going to get rid of that. Our equation was on one side, 12x plus 81. And Madison's right. You can enter just 12x plus 81. The only time you absolutely have to enter the y is if you just have a number and no x. All right, and the other side was 24x plus 9. 24x plus 9. Y'all told me if I enter one of these wrong. I did that earlier. I'm like, what did I do wrong? Okay, here's our intersection. What did we get? We got 6. There's the 6. All right, so either way you want to do this, it doesn't bother me. That's why I taught you how to graph these. Oops, wrong page. There we go. Okay, so it not only asks us for x, though, on 5 and 6, it also asks us for one of the angles. So let me show you how you would do that. Let me enter x equals 30 and x equals 6 for numbers 5 and 6, okay? All right, so if x equals 30, what they're asking for is angle REC. I'm going to make this a little bit smaller because it's just really hard to see. So on number 5, angle REC. Let's talk about how you find that. So what you do, angle REC, you start at R, you go to E, and then C. So that's this angle right here. That's the 4x plus 10. So they want to know what is the measurement of REC, which is this angle. So we just take our 4x plus 10 and we fill in the 30 for the x. Okay, so we're plugging in. All right, so 4 times 30 plus 10 will give us the measurement of this angle. So sometimes you're just asked for x. Exactly, Madison, thank you. But other times you're asked for x, and then they want to know what's the measure of this angle or what's the measure of this angle, okay? So 4 times 30 is 120 plus 10 is 130 degrees. Now, if they had asked us for what's this angle right here, the angle D, then we would have done 2 times 30. We would have plugged in the 30 for the x there. But they didn't ask us that. They asked us for angle E. All right, on this one, they ask us for TSU. Okay, so TSU is this one. So the 12x. So I do 12x, and I fill in a 6 for the x. 12 times 6 is 72. So 72 degrees. Good, good. All right. We have 2 more. Let's see if we can get through. Let's see. How long have I got? Why can't I never remember this? Oh, I got 9 minutes. I think we're good. Okay, number 7. We have, I'm gonna highlight these. We have, whoops, remote interior, and we have exterior. So if we set up our equation to this one plus this one equals the green one, 39 plus 2x plus 1 equals 3x plus 13. We need to find out what x is. I'm going to pause for a second. I'm going to pause my. So what we did, sorry, I forgot to hit record. We went over, we set this one up equal to 95, and we went over and we did this on one line right here, and we did the y equals 95 on the second line, and we got x equals 17. Now we're looking for this angle, 3x minus 16, and we're going to fill in a 17 for the x. 3 times 17 minus 16. Anybody want to put that in a calculator and tell me what you get? Again, if you didn't get all this, it's okay. I'm going to share the completed notes with you guys later, and you can go back and fill in anything that you didn't get. I'll also share this video that I'm recording right now. I'm going to try to put it on the Cami directly. If I can't, I will put it in an announcement. Yes, sorry. You are correct. So FGH is 35 degrees. All right. I have 3 minutes. I want to show y'all something. Let me stop this recording.